Hello, my name is Alex Benesh, and in this video, I'm going to talk about data privacy and the solution that we have come up with to address data privacy uh, in terms of regulations and government requirements. Uh, the requirements in many cases from governments and regulatory bodies is to access aggregated private data about individuals or corporations, and the challenge is how to share the private data as input to aggregated data without revealing the actual data, the private data itself. So this could be a challenge for banks, exchanges, federated institutions such as business associations and similar institutions. So some of the case studies we're going to do here, one is the number of exchanges being required to share an account balance for an account holder. So this could be crypto exchanges, it could be fiat exchanges, it could be banks or similar financial institutions. And this would be to satisfy anti-money laundering scenarios. And in many cases, such institutions, such as banks or exchanges, cannot reveal private data outside of their jurisdiction or to any outside source without a legal requirement. So the question is, how do we address this? So let's say we have five exchanges, and the regulations forbid the sharing of customer private data. And let's say anti-money laundering regulatory body requests a total balance for an individual across all exchanges. So let's say we have five exchanges here, and you have a bad actor who comes in and deposits, let's say, less than $10,000 per exchange or bank, it could be either one, just to stay under the radar of the AML radar. And so the total balances would add up to a substantial amount, but the individual balances would be, let's say, less than 10,000. So let's say the government comes along and says, hey, I need to see the aggregated balance for this account holder. Now, since these amounts are less than 10,000, these exchanges or the banks may not be required or may be forbidden, in fact, to reveal this amount as private data. So how would you go about satisfying this regulatory requirement? So the algorithm would basically involve sending a random number from a data aggregator. Let's say our company Kodak would create this aggregator, and the random number would be sent to one of the institutions, which would add its own balance to it. So it would be, let's say, 1,000 plus 9,100. And then it would send it to the next institution. So at this point, the balance would be 10,100. This institution would add its own balance, let's say 9,200. Now, if you note here, the second institution would not know what the balance of the first institution is. And so on and so forth. So this balance would get passed to the other institutions until it goes back to the aggregator. So in this case, the total amount would be, let's say, 47,500. And the aggregator itself would have no idea what the individual balances are of each of these institutions. So at this point, the aggregator has the total amount, and it knows that it sent 1,000, the value of 1,000, which is a random number, to all the players in this network. So it received 47,500. It would deduct 1,000, and the final balance would be 46,500. So the regulators would receive the total balance for an account holder and the audit trail could be deposited in a database or on a blockchain. So the regulatory requirement has been satisfied, and no private data has been revealed to any of the other exchanges within this network or to the aggregator. The second case study would be for an industry association, for example, trying to publish monthly or annual sales. And many of the members may not be willing to reveal their total sales. So this is the same scenario. Basically, you would have a number of hotels, and they'd be required to provide their sales to head office or headquarters in a private manner, so that the head office can, for example, publish total sales. In many countries, the hotels or associations may not be willing to reveal their actual sales for tax purposes or for private purposes. So basically, this would be a scenario where an aggregator would address this issue. So you'd have the association, you would have the hotels, and each of them have sales of different amounts, 1 million, 2, 3, 4, 5. And again, would go ahead, the aggregator here from the association sales, from the head office of the association, would send a random number, let's say 0.5 million, to the hotels, and the hotels would simply add their own amount and pass the amount across the network, and it would go back to the aggregator or the head office, and then it would simply receive, let's say, 15.5 million in this case. And since it sent 0.5 million as a random number, it would simply deduct that, and it would have the total annual sales of 15 million. And in this way, none of the private data has been revealed to any of the other players within this network. And the requirement to aggregate the sales has been satisfied. And the third case would be basically taking a vote. Let's say we have and it's the same association requiring the members to vote on admitting a new hotel, a new member. So how do we go about doing that? In this case, each vote of, let's say, yes vote would be equivalent to let's say, value of 1, and a no vote would be -1. So the aggregator or the head office would send a random number to the first hotel, and then it would add the number to its vote, which is a yes, which would be 1. So the vote up to this point would be 3. The second hotel is going to vote no, so you subtract 1, and then so on and so forth. So the final vote would get back here. The final vote was 3, but the random number was 2 that we sent. So the aggregator or the head office would subtract the random number from the final vote. So the final vote is 1, which means to admit this new hotel. So now to the actual implementation of this algorithm. How do we go about implementing this logic in a network environment? So let's say we have 3 exchanges or banks, and the regulatory body requires that we provide the account balance for a particular account. We would have an aggregator in Node.js or JS, and the aggregator would use a homomorphic encryption to send a random number. It would take a random number, it would encrypt it, and with a public key it would send it to one of our APIs that we would supply the exchange, and that API would simply communicate with the private API at that institution, which would do a data dip and look up the balance. The balance would then be added to the random number in a homomorphic mathematical operation. To the API here, the original encoded balance is not visible because it's encrypted. However, a mathematical operation is possible on this encrypted object. Once that operation has been performed, the object would be passed to the next API at the next institution, and the same operation would be done. A balance would be retrieved locally at the institution, and it would be added to an encrypted object using the public key without the API here knowing the actual final amount or maintain the actual balance once it's been looked up. So these are completely atomic, and none of the nodes here have visibility to the account balance of the other ones, nor does the aggregator. So this process would continue, and then at the end, once all the amounts have been aggregated, then the encoded balance would travel back across the network, and then it would land with the aggregator, who would have the private key for this encrypted object, and it would decrypt it and would deposit it into a local database or a blockchain. And at no point would the aggregator have any visibility to the balances of any of the member nodes. And the member nodes have no visibility to the other nodes, and all the mathematical operations are done in a encoded manner. And the algorithm is done in a homomorphic encryption. Okay, so we covered the design documents. So now onto the database and the front-end portal. So we have tables for the individual branches, the exchange or the bank branches, and in each of these we have some accounts. So let's say this branch is holding these accounts. So let's say ABC123 and SBPVP. And if you notice, we have those accounts in the various different branches. So we're gonna work with 3 branches, branch 8,000, 9,000, and 10,000. So if I go with 10,000, there should be balances for these accounts, and these are the accounts that the regulators would be interested in. So now if I go ahead, let's go ahead and try and look up an account. I could say choose, and I see that I have these 2 accounts that we saw in the database. So let's say go with ABC123. I add that and I say confirm, and I'm going to ask for it to be updated. So the request is going out, and if you notice, this is our aggregator. I'm receiving the request, so the aggregator is going to talk to the first node, to the first branch, to the second one, and to the third one. So it obtained 301, 600, and 400. So this should be 1,301. And if you notice, the aggregator receives this number, which includes the random number that it sent. It subtracts the random number, it gives 1301. So if I go and say display, it should update it. Yeah, and so basically the timestamp changed, and it is the 24th of June, and this is the timestamp here. So let's go ahead and choose another account. Let's look up the balance for this account and say confirm. So here we go again. So this is sending out the request. So the request should come in here after I update it. So the request came in here, and it's going to go to the first node. Okay, so I got the balance of 2,300. got the balance of 102, and it got the balance of 200. So here it's going to receive all the balances now. So this is the balance from the nodes, which includes a random number. It subtracts a random number, and it shows the final balance. If I go ahead and say display, changes the timestamp, my balance is 2602. So then again, if I go back to my database, you'll see that the SBPVP, the balance for this account is 200, and if I go to port 9000 to the branch 9000, it is 102, and if I go to 8000, it is 2300, and the total as we got was 2602. So this was done completely in a private manner. There was no sharing of data amongst the nodes, and there was no visibility to the private data in flight or statically by any of the nodes or by the aggregator. So we managed to obtain the balances across a number of different nodes without any of the nodes finding out the private data from another node. At the end of this video, I'm going to share the links at the bottom of the video and in the comments below, and if you have any questions, you could contact me. Thank you.